Here we are, topic 1.2, Math 20-1. We're moving on to arithmetic series. Carl Friedrich Gauss was a mathematician born in Germany in 1777. He's noted for his significant contribution in fields such as number theory, statistics, astronomy, and differential geometry. When Gauss was 10, his mathematics teacher challenged the class to find the sum of the numbers from 1 to 100. Believing that this task would take some time, the teacher was astounded when Gauss responded with the correct answer of 5,050 within minutes. Gauss used a method that was much faster than adding each individual term. First, he wrote the sum twice, once in ascending order and the other in descending order. Gauss then took the sum of the two rows, which was 101 plus 101 plus 101, 100 times. And he realized that since he had twice too many numbers now, he could divide that by 2, and 100 times 101 divided by 2 is simply 50 times 101, which is 5,050. In determining the sum of the numbers from 1 to 100, Gauss had discovered the underlying principles of arithmetic series. And that's what we're going to take a look at today. Arithmetic series is the sum of the terms that form an arithmetic sequence. And for arithmetic sequence 2, 4, 6, 8, the arithmetic series that is represented by 2 plus 4 plus 6 and plus 8. Now then, Sn represents the sum of the first n terms of a series. In the series, 2 plus 4 plus 6 plus 8 all the way up to whatever, S4 is the sum of the first 4 terms. You can use Gauss's method to derive a formula for the sum of the general arithmetic series by saying T1 plus T1 plus D plus T1 plus 2D all the way to the end. And for this series, T1 is the first term, N is the number of terms, and D is the common difference. And what it's going to happen is you're going to end up with this equation. The sum of arithmetic series can be determined using this formula. Sn is equal to n divided by 2 times 2 times the first term plus n minus 1 times the common difference. Now, we're going to use this form of the equation when we don't know the last term. You're going to see on the next page that we're going to use a simpler form of this if we can find the last term. Now, as you can see, a variation of this general formula can be derived by substituting Tn for the formula for the general term arithmetic sequence. Now, what they've done here is that they've taken the term that was on the sum that was on the previous page. You split up the 2 times term 1, and what you're going to get is this term 1 plus n minus 1 times d. And remember that that's the same as Tn. So if you substituted Tn, the last term, with all of that mumbo jumbo there, you're going to left with Sn is equal to n divided by 2 times T1 plus Tn. This simpler equation is derived from the first equation as long as you know the last term. And here it is, here it is in blue. The sum of arithmetic series can be determined using the formula S sub n is equal to n divided by 2 times the first term plus the last term. And again, probably none of that means anything until we show you how it works in an example. So let's determine the sum of arithmetic series. Male fireflies flash in various patterns to signal location or to ward off predators. Different species of fireflies have different flash characteristics, such as intensity of the flash, the rate of the flash, and the shape of the flash. Suppose that under certain circumstances a particular firefly flashes twice in the first minute, 4 times in the second minute, 6 times in the 3rd minute, and so on. And if this pattern continues, what's the number of flashes in the 30th minute? We also want to know what's the total number of flashes in 30 minutes. Well, here we go. We need to, first of all, figure out what the 30th term is going to be. We're going to use our equation that we learned last day. Tn is equal to T1 plus n minus 1 times d. And we're going to say that Tn is going to be T30, is going to be the first term, which is 2, plus n minus 1 is going to be 30 minus 1. And the common difference, well, it goes up by 2, so the common difference is 2. So now we can tell what the 30th term is going to be, because 2 plus 29 times 2, 29 times 2 is 58, plus 2 is 60. So the 30th term is 60. Now we can take our equation, S sub n is equal to n divided by 2 times T1 plus Tn, first term plus the last term. We know the first term, we know the last term, so we can say S of 30 is going to be 30 divided by 2 over 2 plus 60. And that's simply going to be 15 times 62, or 930 flashes in the first 30 minutes. You can do your turn on your own. Okay, for our last example today, we're going to look at a harder problem. Determine the terms of arithmetic series. The sum of the first two terms of arithmetic series is 13. The sum of the first four terms of arithmetic series is 46. Determine the first 6 terms of the series and the sum to 6 terms. So here we go. What we're going to first of all do is that the sum of the first 2 is 13, the sum of the first 4 is 46. So we're going to make an equation. We're going to substitute both of these sums into our equation. Sn is equal to n divided by 2 times 2 times the first term plus n minus 1 times d. Now we're using the equation in this form because we don't know the last term. For S2 equals 13, sum of 2 is 13. We're going to say the sum of 2 is going to equal 2 divided by 2, and it's going to be 2 times term 1 plus 2 minus 1 times d. 2 minus 1 is 1d, and 2 divided by 2 is 1, so we're left with the sum, which is 13, as we're given, is equal to 1 times 2 times the first term plus d. Now we don't know d, so we got to keep working. 13 is 2 times the first term plus d, and now we're going to start with that. That's as far as we can go, so we have to now start with the sum of the first 4. And that's going to be the sum of the first 4 is 4 divided by 2 times 2 times term 1 plus 4 minus 1 times d. And 46 is going to equal 2 times T1 plus 3D, and then if you divide both sides by 2, you're going to get 23 is equal to 2T1 plus 3D. So now I have two equations with two unknowns. So I'm going to put them together and solve a system of equations. And that is going to be 23 equals 2T1 plus 3D, and 13 is equal to 2T1 plus 1D. If I subtract these two equations, I will eliminate my 2T1s. That's one of the methods of solving a system of linear equations. So therefore, the 23 minus 13 is 10. The 2T1s are going to cancel to leave me with 2D is 10. And of course, D will equal 5. Now that I know that, I can say that 13 is equal to 2 times term 1 plus the common difference. Now that we know the common difference, it's going to be 2 times term 1 plus 5. Divide or subtract 5 from both sides. Divide both sides by 2. And you're going to find that t is equal to 4. For our series, it says to list the 6 terms. If you know the difference is 4, we know the difference is 5, and the first term is 4. So you get 4 plus 9 plus 14 plus 19 plus 24 plus 29. And using our equation, where we know the first and last term, Sn is equal to n divided by 2 times t1 plus tn, the first term plus the last term. Now that we know the first term and the last term, we don't have to use that big ugly equation. We can use the short one. And you get the sum of the first 6 terms is 6 divided by 2 times the first term 4 plus the last term 29. Again, you're going to get the sum of 6 terms is 3 times 33, or 99. So in summary then, our key ideas: given the sequence T1, term 2, term 3, term 4, all the way up to term n, the associated series, the sum of all n terms, is the first term plus the second term plus the third term plus the fourth term, all the way to plus the last term. For the general arithmetic series, T1 plus T1 plus D plus T1 plus 2D plus plus T1 plus n minus 1 times D is going to give me the general series. The sum of that series is going to be Sn is equal to n divided by 2 times 2 times the first term plus n minus 1 times the common difference. We're going to use that equation when we don't know the last term. Or the sum of the first n terms is n divided by 2 times the first term plus the last term. The second equation is very nice to work with, much easier to work with, but it doesn't work if you don't know what the last term is going to be. And thus ends our lesson.